Picture this, almost 6 miles above the earth. You are alone in an open basket, dangling under a hot air balloon. The air is very thin. Every breath depends on the oxygen mask strapped to your face. The temperature, 65 degrees below zero. And in that freezing silence, you are struggling to keep the burner alive and to keep yourself alive. That's what Bruce Comstock did in 1995. He climbed to 30,820 feet in a hot air balloon, one of the highest flights ever made without protective gear. Hello friends, welcome to Lighter Than Air, Science and Flight. I'm Sitara Maruf, and together we will explore the science, innovation and adventures that push the limits of what is possible. Today our guest is Bruce Comstock, one of the most accomplished balloonists of our time. For more than 40 years, he set records for altitude, distance, and duration. He designed the first autopilots and altitude alarms for balloons. He and his wife built one of the earliest balloon manufacturing and repair business in the US. And when adventurer Steve Fossett set out to cross oceans and circle the globe by a balloon, Bruce was right there, making it possible. His book, A Life in the Air, tells about his adventurous, record-breaking flights to the struggles and innovations behind them. But today you will hear it in his own words. So let's begin with the story of the daring flight to 30,820 feet.
It's a tricky situation because that altitude is above about 70% of the atmosphere. So that aren't as many oxygen molecules as one would normally like. I think the useful time of consciousness, if you stop breathing, is something like 30 seconds, which means if your oxygen system fails and you don't notice, you basically die. Because once you lose consciousness, you're in a very bad situation. So I had to be very careful about that. I was able to borrow an oxygen mask and regulator from a friend of mine who had flown the fours in the Marines and had done some world records. So we had a really good oxygen system and a backup oxygen system, which was a very simple one, but would have been enough to keep me going at that altitude. It's the preparations, organizing oxygen very carefully, making sure that you have that. But the other problem is balloon burners don't work usually at 30,000 feet.
Yes.
They kind of work once you get to, in the case of me, once you get to around 25,000 feet is when I turn the burner on. The flame would start working initially, but then the base of the flame would lift off the burner. Once that happens, it goes out. And then you're just spraying unburned propane into the balloon envelope. I modified the jets. I put different jets in the burner, and on one pilot light for one of the two burners on the balloon, I fitted supplemental oxygen so that the pilot light would keep working. If the burner flamed out, I'd turn the main jets off and then turn them on again. So it was a lot of thinking about what I need to do to make this all work. I was able to borrow, at that time I wasn't part of Cameron Balloons US anymore. It was just after I left. And I was able to borrow a balloon from them, which was very generous of them. It was the right size balloon to get me up to that altitude. So it was an interesting flight.
Yeah. And it was a hot air balloon, so you just had hot air, right? It was not a
Yes.
Roziere. It was a hot air balloon.
Yes, that's true. In a gas balloon, it was easier to go high because you just take a bigger balloon and you can go as high as almost as high as you want. With a hotter balloon, you have the trickiness of having the burner work. And also because the air density is so low at 30,000 feet, you end up with a fairly high envelope temperature.
Yes.
That's balanced by the fact that it's really cold. It was 65 degrees below zero Fahrenheit at 30,000 feet. But the envelope temperature was around 250 degrees. So I had a differential of like 315 degrees, which is really unusual. And that was enough to support weight in the thin air. The air density there is about 28% of what it is at sea level. So you have to have a much bigger balloon, and it'll wait for a temperature difference to generate enough lift in that really in air. It was a very interesting flight. I want to backtrack just a bit. I mean, the question is, why did I do this?
Yes.
That's always people's questions. Well, what happened is the International Aeronautic Federation created what they called a pilot badge system, but basically it was a structure of tasks that people could complete. They had different levels. They had a silver level if you completed all the silver level magnitudes in each of those tasks. The tasks were distance, duration, altitude. There was a competition accuracy one where you had to fly to a target from something like 5 kilometers away and drop a marker within 1 meter of the center to qualify for the highest level. When they set up this system, I read about it and I realized that I had done everything for the highest level. Not just the highest level, but the gold level with 4 diamonds.
Yeah.
In other words, the greatest distance flown and the greatest duration and competitive accuracy. But the one thing I hadn't done for the highest level in the system of everything was a flight to 9,000 meters, which is about 29,000 feet. So I decided to do that because I thought, well, this is pretty cool. I've already done all the other stuff and I can produce documentation for everything except and done the flight to 9,000 meters. So I thought, okay, I can do that. That's an interesting project. And I set about to do it then. And the reason I went to above 30,000 feet is I don't think in meters of altitude. In fact, almost no one thinks in meters of altitude. And I also like big round numbers. So I thought 29,000 doesn't sound it sounds like you tried to go to 30,000, you didn't make it. So that's why I picked 30,000. And what happened on that flight is, as I said a bit earlier, that I started having problems having the burner flaming out at about 25,000 feet. I ended up having to take a glove off in order to do this, which made my hand cold. But I would just open the blast valve a tiny little bit. It's a toggle valve, and I would just open it a little bit, and I could kind of keep the burner working better that way. But my hand started hurting a lot, and then my hand wasn't hurting anymore, and I realized that was a really bad sign. So that it got so cold, I didn't have feeling in it, so I quit doing that. And then somewhere just over 30,000 feet, I thought, okay, this is my goal. I knew that was the goal for the flight. And I was struggling with the burner, and I thought, why would I continue to try to fly higher? Because I met the main goal of the flight. I was having problems with it. I was also spraying a lot of unburned propane into the envelope. I didn't like the idea of that.
It could have ignited if the propane was leaking in the envelope?
That was in the back of my mind. I was thinking, that'd be really exciting. And of course, the balloon would disintegrate and fall to the earth, and that'd be a very bad ending. So, okay, it's time to quit.
Now, conventionally, balloon pilots cannot fly above 18,000 feet, correct? Because air traffic control has that separation between balloons and other aircraft. So obviously, you had to also take clearance from the Federal Aviation Administration. And then did you also anticipate all the dangers of flying into high altitude?
That was very interesting. I called the Route Traffic Control Center in Cleveland, which is the one that covers southern Michigan.
Yeah.
And told them what I was interested in. And very quickly, I was talking to the man in charge of, gosh, I forget what it is, but basically the pattern of restrictions in the area that they covered. And I was well prepared. I approached my local FAA office, and that was an interesting set of conversations. They said they couldn't really give me permission to do this, and that they had to bump it up to Washington. When they said bump it up to Washington, in my subconscious, I heard a loud flushing sound, because once something gets sent to Washington, nothing happens for years. I knew that. So in fact, he thought I needed a special kind of permission that I didn't really need. And I then went to the Air Route Traffic Control Center in Cleveland and talked to them. The guy there said, and I was very apologetic. I said, I've got this plan. I'll take off really early in the morning, maybe even before sunrise. That way I wouldn't be interfering with the passenger jet traffic between Detroit and Chicago, because I have to ride pretty much in that route. And when you get up to 30,000 feet, that's where the jets are flying. And then I would only be there for a certain amount of time, and then I'd be right back down. His response was, you have as much right to be there as they do.
Oh, wow.
I thought, okay, this is so I got that sorted out, and I never bothered with the interpretation from the local FAA office, which was that I needed special permission. Because I assumed if the people in charge of managing traffic in the air had given me permission, it was going to be hard for anyone to claim I'd violated some law. So that all worked out. And then the other thing that was great about them is I said, I'm going to be standing in an open basket, and the temperatures are going to be horribly cold. There's all kinds of considerations that make it difficult. So is it possible to not have to switch communication frequencies? Because in order to make the flight, I had to talk to air route traffic control people. Normally, if you're flying an airplane, they give you a new frequency for a different controller. You have to turn knobs, and so I had 3 layers of gloves on, and my was inside a box that kept it warm with a plexiglass top. He said, no problem, I'll organize it so you can just be on one frequency, and one controller will control everything, and he'll talk to anyone else that you would normally need to talk to. So it was really wonderful how cooperative they were.
So you did have good communication equipment, and then besides the air traffic control, were you in contact with anybody else on the ground?
No, I was focused completely on getting the balloon up to 30,000 feet.
Yes.
Staying alive and healthy in the process.
Yes.
And the weird thing is, after I took off, I had a radar transponder, which I had to have to fly above 18,000 feet, because there's no way they could have someone flying up there and not know where they are. So I had a radar transponder and a communication radio that was marginally effective. Actually, it was an old radio and it was hard to understand. I took off and called air traffic control on the frequency that they'd given me. They responded, free balloon, whatever it was, negative radar contact. And my heart sank when they said this, because there's no way I was going to be able to go above 18,000 feet unless they could see me on radar. When I got to 3,000 feet, I heard the call from the controller called, said, whatever it is, CB, radar contact. And I thought, okay, cool. There's nothing needed. But what they also did is they gave me what they call block airspace. And they gave me a cylinder of airspace around me from the surface to 32,000 feet, which meant that even below 18,000 feet, I think they did this. And anyone under air traffic control, they vectored them around that cylinder. And of course, the cylinder was moving because the balloon, but that was my private cylinder of airspace for the entire flight.
Now, at high altitudes, say beyond 20,000 feet, how does the thin air affect the ascent and descent of a balloon?
It's advantageous because air produces drag. And in order to climb, one of the things you have to do is overcome that drag. The drag may be equivalent to about 500 or 1,000 pounds effect. But so that's one thing. But coming down, it's advantageous because you can come down fairly fast without the balloon caving in as much as it would at lower.
Yes.
I was surprised at how nicely the balloon descended. So it's basically a cold descent. It wasn't exactly cold, but it wasn't heating. It heated very little on the way down, and the balloon stayed nicely inflated. At these higher altitudes, I could come down pretty fast because the air is so thin.
Okay. Now, you mentioned the difference in the temperature outside temperature was minus 65 and the envelope was almost like 250 or something. So the difference in the temperature was almost 315 degrees Fahrenheit. How is it in the immediate surrounding? Here you have an envelope that is almost like near 300 and then minus temperature outside. So is there some physical effect around you over there because of the temperature difference? Or it's just normal?
It all just works.
Okay. Now we will move on to your Aspen, Colorado to Altoona flight. Before we talk about your remarkable flight, could you explain how an autopilot works and how it supports long-distance ballooning? And you can talk about your manufacturing the autopilot too.
One of the things after I got involved in ballooning, one of the things I realized was it would be possible to make a device that would sense air pressure and keep a balloon level, or it would be doing an autopilot. So I set about learning what I needed to learn about electronics to do that. And that was way back into the late 70s. So it was before the internet and before digital computers. I learned enough about how to design analog circuits, what are called analog circuits, that use voltages to represent. And it's really hard to do anything with that. But I've been fiddling with that. I made a balloon flight simulator, and then I built separately a kind of balloon flight autopilot, and then I had the autopilot fly the simulator. But I mean, it's all just fiddling around in my basement. And then I actually built a functional analog balloon autopilot, a really minimal one, and flew it, and it worked, and it was not very highly developed, and so on. And Don Cameron knew about it and told Steve Fossett if he wanted a balloon autopilot, he should talk to me. So he did. He said, I'm going to be flying across the Atlantic Ocean, and divulged the fact that his real goal was an around the world flight. Steve was very secretive, I guess, maybe is the word, or held things close to the vest. And he said so he's going to make this flight across the Atlantic Ocean, and really wanted an autopilot. And he talked to me in the summer, maybe early summer, and he would have needed it by August, September, somewhere in there. I said, Steve, I can't do that. I mean, I don't have time. There's not time to do the development of something that would actually be reliable and workable. Yeah. He asked me several times, and I gave him the same answer. But then it turned out my friend Tim Cole was flying with Steve on that flight across the Atlantic. And Tim was really experienced hot air balloonist and gas balloonist and multiple gases. I mean, all the ones I named, hydrogen, helium, and ammonia. And he called me and said, hey, Bruce, could you make an autopilot? So for him, as a simple favor, I did. It was a toy. Many times I've described it as a toy, but they used it on that flight across the Atlantic a little. Basically, Steve ended up owning it. So when I went to help Steve launch from Seoul, Korea on his Pacific flight, our goal was to preserve all possible duration on that flight so that if things were going well, he could just keep going. Nobody really knew that. It was kind of like a thought in the back of his mind that he just keep going across the Atlantic too. He didn't do that, but he did use this toy autopilot. And after the flight, I asked about it. I said it would drift 600, 800 feet off altitude in a couple hours, which didn't surprise me at all because that one didn't really it didn't measure air pressure. That one just used the rate of climb instrument.
Yes.
And it calculated elevation kind of backwards from just watching all the rates of climb up and down. But it's never going to stay on altitude reliably because there'll always be a little bit of error in the rate of climb input, either up or down, and then you drift off altitude for that much. So he told me that. I said, Steve, you need good autopilot, and I can make you one. In fact, I would want to make you two. A good way to get reliability is to have two. And if something happens with one, you just switch over to the
Yeah.
other one.
Okay. Okay.
So that's where the good autopilot came from. And you asked how that works. Well, I'm not going to provide all the details, but
Yeah. Does it detect bad weather or shifting winds, and does it change the balloon's altitude automatically?
no,
No.
no. Its sole purpose was to keep the balloon at a constant altitude without any other considerations. The way it did that is it did have an altitude air pressure sensor, and it also used input from a very sensitive electronic rate of climb. If it got displaced from the desired altitude that the pilot wanted to maintain, it would come back on its own. It would fly the balloon back to the desired altitude, either down or up. So it was a digital computer. It was a single board industrial digital computer I used. And I just had to learn my sixth, seventh programming language.
So when you flew from Aspen, Colorado to Altoona, that time you tested the autopilot and it did stay level for more than 12 hours. You slept for 6 hours and your co-pilot slept for 6 hours, but the autopilot maintained an altitude of 12,807 feet.
Yeah, that was pretty remarkable. I was exhausted by then because I had virtually all the responsibility for this flight. Ed had approached me and said, hey, I bought Steve Fossett's Atlantic balloon. I thought we could make a really cool flight. I don't remember how it became from Aspen. It was going to be Aspen to the Atlantic. Ed announced to me after I agreed to do this that this is the Aspen to the Atlantic flight. I said, Ed, that's putting a lot of pressure on me.
Yeah.
We can fly east quite a ways. I don't know if we can the Atlantic, but he paid for everything. He said, I'm going to buy the balloon and I'll pay all the expenses. I'll pay for the gas. I had a good friend involved in a company that sold helium. And the important thing wasn't just being able to get the gas. I mean, we didn't get a special price, but the key was to be able to get the gas on short notice. It was 40,000 cubic feet of helium. I set up an arrangement where we would talk each day and I would see what the chances are that we would need the helium for 2 days, the morning, 2 days later, or that'll be the afternoon, really. So she really helped out. I organized a hot air balloon basket that we used. Normally it's a ride basket. It had partitions. I got it all set up so it could have seats because it was a long flight. And
It was an open gondola, that one too, right?
no, it's just an open basket. It was a cool flight because mostly people only had the incentive to do long distance flights or set a record or some remarkable flight. But what Ed and I were doing was just a weekend pleasure flight of almost 2,000 miles. We took about Friday evening and landed Monday morning. So we were up 3 nights.
Yeah.
And it was just a really remarkable experience.
Sorry, go ahead.
Yeah, making a flight like that, it requires virtually the same kind of preparation that you would make for going into Earth orbit. Once you take off, you can't stop at a McDonald's or pick something up that you forgot. You have to take everything you're going to need for the entire flight. In our case, it was 3 nights and almost 2,000 miles. It's like going into space, except we didn't go higher than 18,000 feet because the rules.
Safety and rescue are critical on any balloon flight, but what instruments did you rely on to send messages in case of emergency?
When I undertake something like this, I do very careful planning, and a lot of the planning involves what can go wrong. From looking at the things that can go wrong and the degree of seriousness, I develop a plan B, a plan C, and a plan D, and make sure I have all of our stuff. There wasn't much that could go wrong, really, if we're just careful and if we pick good weather. So it was a very relaxed flight. I mean, there were a few weird moments, like when we were near Kansas City, I think. It was midnight, and we're at
Mm.
12,000 feet, 11 or 12,000 feet.
Yeah.
And I had the radio on. I was listening. Well, I was hearing passenger jets, which is a little off-putting. So we had the transponder on, and that made me a little nervous.
Yeah. Yeah.
And there's something about night in a balloon. Night is completely different from day. I learned this years before when we'd made some hot air balloons where we took off way before dawn
Mm-hmm.
with enough fuel so we could land right at sunrise when we could see things. It's just a completely different world at night. You're higher, like we're 10 or 12,000 feet at that point, and you're cold because the sun is gone and the air gets cold.
Flying over the mountains, especially in Colorado, where there are 14,000-foot peaks,
Yeah.
and you were in the dark, it was nighttime. How does flying over the mountains around them, how does it affect the balloon or the wind pattern? Is it different? Of course, it is dangerous. It's a daunting task.
There was an Austrian balloonist at both gas and hot air who'd written a paper on mountain flying. I had no mountain flying experience. I'd flown in some mountain valleys in nice weather, did little hot air balloon flights for an hour. But
Yeah.
never over mountains. And what this guy said was stuck in my mind. If the wind at the elevation of the terrain is 30 knots or more, that's dangerous. And the reason it's dangerous is if the wind of ridges is that fast, it'll create what's called mountain wave. As air gets pushed up by the ridge, it goes to higher than it wants to be for its temperature, and then it falls down again, and it goes too low, and then it goes up again, and you get these waves out from the mountain. And you don't want to be flying a balloon in that. It's an untenable situation. So I paid attention to that, and I checked the winds of law forecast and the observed winds of law very carefully before we took off on that flight.
A high pressure ridge, I believe. How does high pressure ridge help in ballooning? You launched around sunset time owing to the high pressure ridge, right?
What happened is I had a guy who was a meteorologist, and we were consulting on the weather. He was trying to find a really good situation. I don't really know what data he was using to pick it, so because he hadn't done it meteorology for balloon flight. And in the end, I thought Don Cameron told me that when people are trying to fly the Atlantic Ocean, he said the way to do a flight across the Atlantic Ocean is to wait until a ridge comes, pressure
Yes.
with the ridge. All ridges are high pressure, and then insert the balloon into the ridge. There's takeoff right when it's passing. What happens then, due to the way air flows in the atmosphere, is ahead of a high pressure ridge. The air in the northern hemisphere tends to go more to the right. Behind it, it tends to go more to the left. If you're in the northern hemisphere and you're looking down like you were God and there's a high pressure system, the air flows clockwise around it.
Okay.
The ridge is like a pressure system swooshed together, and the air in front of it tends to go more to the right, and the air behind it will go more to the left. So the reason you want to insert the balloon into this situation is if you're flying along during the flight and you're going too far to the right,
Yeah.
you go down, you slow down normally when you descend. You go to lower altitude, you slow down, and then you start going more to the left. So you can basically steer. And the other thing is that high pressure is good weather. So it's a real
Right.
bargain. I just saw a ridge coming, and I didn't get a lot of consultation with my
Yes.
meteorologist buddy on this, but we saw a ridge coming. I said, okay, we want to take off at such and such time. And it turned out the time to take off was Friday evening.
Mm.
And we did that and got in that ridge, and it worked great. We flew almost straight across the U.S. at 90
Yeah.
degrees. Although one time something happened around Kansas City where, for reasons I never understood, as we turned from a 90-degree track to about 120,
Yeah.
or 225-degree track, which is very distressing because we didn't want to go there, but then that sorted itself out. But I think that was during that whole experience at night with the passenger jets and all that.
Yeah. Now let's move on to Steve Fossett's solo Pacific flight. And I believe he contacted you and he said he asked you to be launch director. He wanted to take off from South Korea and you politely declined. But then you had a friend, Nick Som, who called you and said that Steve asked him to be launch director, but he would agree to do that only if you would be the co-director of the launch. And then you accepted it. So it must be tremendous responsibility for a launch director to be a launch director for somebody who wants to fly solo across the Pacific. So did that help you because Nick Som agreed to be a launch director and you thought, okay, fine, you can take the responsibility?
Basically, yeah. It meant that there were two of us who could discuss things and share the responsibilities. There were many times when that was advantageous. I worked with Nick on 3 launches of Steve's, the Pacific one, the one from the Strata Bowl, and the first St. Louis one. We didn't come in at the beginning, really, of the project. So we were presented with whatever Steve and other people had decided was the right equipment to use. It was a little bit irksome at times, but our job was to make sure everything was ready, everything was working and everything was ready. And then to inflate the balloon. It sounds easy, but like the one in St. Louis, we had a problem. Discovered a minor manufacturing error, and I talked to Don Cameron, who was driving somewhere in Europe at the time. He told me the manufacturing error was unimportant and asked how we were going, and when we were going to launch, and at what stage we were in the inflation. And we said, I told him, and he said, it's not possible for you to get the balloon assembled and
Yeah.
launch in that amount of time. I said, we're going to do it. And we did.
Yes, that was amazing.
It'll take 24 hours. It takes 24 hours to inflate one of those balloons. There's a lot of assembly involved. We had engaged a lot of hot air balloonists and briefed them on what to do, and they had to piece things together.
Yeah.
Basically kind of assembling this complicated balloon envelope in the field in St. Louis. But no, we did it. That was not a problem.
What were the challenges you faced in South Korea? Here was a different country and the volunteers, were they used to ballooning? And you had to wait for the ethane to arrive because propane would not work at minus 40 degrees. So you solved that problem by getting a fuel mixture of ethane and propane.
That was an example of Arden having not been involved in the earlier planning.
Yes.
That was the first flight where Steve would be flying really high. On the Atlantic flight, they didn't fly super high, which means cold. Higher. And on the Pacific flight, Nick and I were in Seoul, Korea, trying to get this equipment ready. We would meet with Steve basically once a day. We have dinner with Steve, but Nick and I realized this isn't going to work. When he gets high, going across the Pacific Ocean, the fuel is going to be too cold to vaporize and the burner won't work. And the flight, you'll have to descend and the fun be over. Nick and I worked on it for a while. Nick was a PhD from Colorado School of Mines. So he's like a sharp guy when it came to science, but pretty good in that arena. And we were sharing this incredible suite at the hotel in Seoul. So we'd sit in our living room and talk about our options. I mean, we're both very wide-ranging people when it comes to thinking about how to solve problems. We consider all kinds of different things, like would this work? I had done some experiments with ethane before the World Championship in Sweden, 70, that was 79. And 79. Because it was the winter and it was going to be cold, and they were going to provide us with ethane, they said. So I bought some and did some experiments flying a higher balloon. It's a certain amount of familiarity with it. I also knew it's very expensive, but it's not like gasoline. So we ended up settling on that. And then at dinner, I presented this to Steve. I said, presented the fact that he had a problem and that Nick and I had considered these various potential solutions. And the one that's clearly the best is to use ethane. And that what we would need is X amount of ethane. It was a lot. I basically apologized and I know this is going to cost a lot of money. I mean, the ethane was about $14,000, something like that.
Yeah.
Then we mix that with the propane, and that gets the pressure up. And ethane is a lot like, it burns just like propane. It's just a smaller version of an alkane series. But basically, it just burns like propane and gives off about the same amount of heat per unit weight. It's perfectly happy to mix with propane, and that was a solution to that problem. But then that left us having to, well, Steve's answer, after I presented this 5-minute description of what the problem we had and what the solution was, he said, okay, I'll order it in the morning. The problem is it took 3 weeks to get it to Korea and get it.
Yeah, to get it from Canada.
Yeah,
right?
in Canada, I think. It had to go through customs. There may have been some bribes paid. Steve was vehemently opposed to any kind of bribery.
Yeah.
We were dealing with a Korean. In Korea, everything is done by bribery.
Yeah. There's about one interesting story about one Mr. Bake, I don't know, Korean person who was helping with the preparations. There's a funny story how when you were waiting for the ethane and when the flight was going to be delayed, so Steve Fossett asked all of you to go back and then return. And Mr. Beck says, Steve does not have heart. If he had heart, he would launch.
Yeah, bad attitude. That's how
So, yeah, it's a great example of the patience required in ballooning. People don't realize that.
I have and Nick certainly did also, but we both have scientific minds. It's something that I think is a big problem right now in our society, is that people not accepting reality and then making stupid decisions. But with science and physics, you can't just decide something works differently than it does. You're going to be doomed if you do that.
Yes.
You have to accept reality and be sure you understand it and then plan accordingly. And Nick and I are both really good at that. Steve was pretty good at that too. Steve was a sharp guy, but he wasn't sharp when it came to the physics and chemistry kind of stuff. But between Nick and I, we could sort it out.
Nick also was very creative. He made those fuel tank certificates for the Korean authorities on the computer.
Yeah, they wouldn't fill the tanks because they didn't have the correct markings on them showing certification.
Yeah.
And there's no way to get that, basically, short of spending a year doing whatever you have to do. That was necessary to produce the documentation.
Yes, that worked. Now, just as the balloon was ready to launch, so Steve was in the capsule. He opens the hatch door and asks you to come and help him or show him how to use the autopilot. What did you do? And most importantly, what did you feel?
That felt a little bit frustrating. But I went and I showed him how to do it. But the problem is there were a few little weirdnesses about it. It required patience because to use the autopilot I designed the program so that the autopilot would watch a human pilot fly the balloon. In other words, the human pilot would, instead of directly use the valve on the balloon, he'd use a switch on the front of the autopilot to turn the burner on, turn it off, and do all of his flying through that. And then the autopilot was watching to see how much heating was necessary. Because when I designed the autopilot, I decided I wanted it to be able to fly any balloon with a burner on it without the autopilot knowing anything about the balloon it was flying. So that the way it would learn about the balloon by watching the human pilot fly it for just a minute.
Right.
There are some parameters, at least a minute, and a certain number of seconds of heating. So it wasn't just a 1 second, because that's too approximate, and in the course of a minute, it's too tiny of a heating. Sometimes it would take longer than a minute. Maybe it would take a couple minutes. I think Steve didn't really engage with that concept that you had to wait. The autopilot would then notify the real pilot that it had taken over. I forget what it was. Some light would flash, and then the autopilot was doing all the flying. Steve had a lot on his mind in his flight, so he hadn't put any thought into how to use the autopilot. I don't know what problems he may or may not have had. It's hard to know.
The heaters also stopped working on that flight. Steve's heaters stopped working on that flight. And then he had a generator problem that he had to fix. He climbed on the fuel tanks at 26,000 feet. Did you anticipate? Now, obviously, it was the first time that he was flying solo over the Pacific. What do you think was the reason for the heaters to stop working?
Basically, the heaters always stopped working. These flights. The people at Cameron Blues Limited had all their great ideas about how they could make them continue to work at high elevation. It was a challenge because these heaters are not designed to work at 30,000 feet.
No.
So they're modifying them and with their fingers crossed. And then part of the problem is having a good supply of propane vapor.
Yeah.
When the fuel was cold, that was challenging to get. So it was a challenge to keep the heaters working. Steve was a rugged guy. He'd put on a lot of insulated clothing. They'd sit there in the cold.
Yeah, no, that was amazing, incredible. But late in the flight, for 8 hours, there was no communication from Steve until he sent that message that now he could see Canada or he was going to land there. What was the reason that the communication was absent for 8 hours from him? Can you recall anything of that?
It's our belief that he turned off the master switch to save electricity,
Okay.
which was weird because it shut off his transponders and shut off everything. He was running low on electricity. He had a generator and some big lead acid batteries, but I guess he was having problems with the generator and he didn't want to use any more electricity, so he just shut off the master switch. But that meant several things. One is it meant the automatic position report stopped. Every 30 minutes, I think there was a position report from the GPS position.
Yeah.
We automatically sent to the communication center, which was in England. And in fact, I was there and people were wringing their hands in despair. And I said to the guy who was in charge of the communication center that I'm not really concerned about this because I suspect Steve has just turned off the master switch to save electricity, which is what he'd done. But then Bo Kemper, this is kind of cool actually, this guy who has had contacts all over high places in Washington, called someone in the Defense Department and was able, there was a U.S. fleet doing maneuvers somewhere in the area where Steve was, and he got them to launch a plane from an aircraft carrier, which found Steve.
Oh.
And reported back. What are the chances of being able to do that?
Now, if we could move on to the first round-the-world attempt by Steve. He wanted to do it solo. Again, you were the launch director, and Nick Som also for this round-the-world attempt. And I think then Steve also had another engineer from England, Andy Elson.
Yeah.
He launched from the Stratobowl in South Dakota. After flying 100 miles over the Atlantic, there was a low pressure that intensified and that was unexpected. And then the snowstorm and the balloon blows back to Canada and plunges in the Bay of Fundy. Steve was rescued by the Coast Guard.
He didn't exactly land in the Bay of Fundy, but he came crashing down.
Okay.
And it hit the water quite hard, apparently. It ripped off the solar array, of course, and the generator even. So
Yes.
my comment after I heard that was that both the generator and the solar array are where they belong, at the bottom of the Bay of Fundy.
Yes.
And that's when Steve asked Nick and I to fly up to where the balloon was and manage getting it packed up and sent back to England. The balloon was pretty well destroyed. It was never flown again. It wasn't repaired.
Yeah.
So we got there, and of course, we're a little depressed about the way the flight had happened. The balloon had some problems with it, separate from
Okay.
weather. Some of the reflective part of the fabric was flaking off. The fabric ended up being defective, or at least not able to stand up to the rigors of that flight. There was a little bit of a problem there, and then he got in the weather problem, and he was just lucky he got flung back onto land. I mean, he had to crash into the water, went back up, and ended up landing in a big pasture, dragging down the pasture. The balloon was pretty well shredded. The local people were very helpful, loaded the balloon envelope with a front loader, bit by bit,
Yeah.
which is not exactly the way you should be handling balloon envelope.
Was it the first time that solar array was being used
That was something that
for electric power?
we got there and discovered. We got there into South Dakota, Rapid City, the Stratable, and discovered that here's this big solar array. It was 5 feet by 8 feet or something like that. And it was going to hang beneath the capsule. And it had a rotator. So a device which would automatically keep it pointed towards the sun. When we looked more closely, we discovered that the entire weight of this big set of solar panels was on a tiny aluminum shaft in this rotator. It hung completely on that, which is ridiculous. I mean, it was doomed to failure. We found a machinist who was able to machine a stainless steel part to replace that, so that helped. But the thing was really cumbersome and not a good idea. See, this is the problem of our not having been involved at the beginning of decisions. That flight was doomed partly by the envelope not working and the solar panel. The electrical system was way too complicated because it had the solar panel, it had the big storage batteries, it had a generator and a charge controller that tried to keep everything working. So when I was in the town where we were recovering the envelope, the very first thing I did after I got there is I'd gone to my room to just put my luggage in it. I thought about this and I thought, we could get rid of the generator. We could get rid of the solar panel. We could get rid of the charge controller if we use batteries, just batteries. Right. It was a simple-minded solution, not very elegant. Well, in my mind, it was elegant. A lot of people would think it wasn't elegant, but I knew how much electricity there was in a simple alkaline D cell. I wasn't suggesting to use those, but I thought, okay, if there's that much electricity in an alkaline D cell, we can find some good batteries that may or may not be expensive. And then we put Bo Kemper, the guy with the contacts in the Defense Department, to work. He came up with the batteries we subsequently used, which were great. But the cost of the batteries Steve used on the flight was over $20,000. I mean, and those were pitched. Those were balanced during the flight. So, but they were just batteries. That's all we needed was batteries, some really good wiring and good circuit breakers. And that was guaranteed to work because it was just batteries, some really good wiring and some good circuit breakers.
So after the round-the-world attempt by Steve, and of course his Atlantic attempt was successful, the Pacific one was successful, but this first round-the-world attempt was within hours the flight failed. After that, you asked Steve, or maybe you had intentions of flying with Steve on a shakedown flight. So why did you feel it was necessary to have that shakedown flight with Steve?
I don't remember all the reasons, really. We prepared for that flight in the hangar that Nick rented in Erie, Colorado, just east of Boulder, which is really cool because my daughter lived in Boulder at the time, and I got to see her a lot. We thought we wanted to do a shakedown flight to make sure everything worked. The previous flight indicated the need for a flight like that. Or even the Pacific Coast did, but to just fly the capsule under a smaller balloon envelope and make sure everything works the way it's supposed to, and then find out if there are any problems. It just seemed like a sensible thing. And Nick and I, we talked to Steve about it, and the idea was one of us would go along, and Nick said Bruce should go along. I'm not sure why Nick immediately said that, but I think maybe he'd had a back injury and a balloon accident in South Africa, and I think he didn't want to put his back at risk. I guess he's perfectly happy to put my back at risk. No.
Now, this was a Roziere balloon. There were some challenges you faced on this flight because you had to reconfigure the fuel system high up. At one point, you were hanging out in the darkness 4 miles above the ground trying to connect a fitting. So you did have some challenges, and you did experience some high altitude illness. Seasickness is what you describe in your book, Life in the Air. You had a headache. So could you recall some challenges from that flight?
That was an interesting flight in many ways. Before the flight, when we were getting ready, that balloon had a vaporizer that had been designed that would burn propane, but its real purpose is to burn a little bit of propane to stay warm, and then that would vaporize more propane used to run other things, like maybe generators, right? When the balloon was inflated and just before we were going to take off, I was trying to ignite that vaporizer, and it was very hard to get it going. A great blast of flame shot out, swept the right side of my face. And my daughter was there, and I went over to where there's some light and asked her to look at it and say, "Am I okay?"
Yeah.
So that was the beginning. But and then we took off. I had asked Steve if he would handle all the air traffic control considerations. Because to me, that's just a nuisance, distraction. And he's good at doing that. We were cleared up to 18,000 feet. And at 18,000 feet, we were inside cloud. And we're going towards the east, towards the Denver airport. And which didn't matter really, because at that if you're at 18,000 feet, it doesn't matter if there's a big airport below because there's no air traffic at 18,000 feet. But we were inside cloud, and I said, "Hey, Steve, can you ask for a clearance for like 4,000 feet higher?" So he did. And I was standing in the hatch on the top. He'd hope that standing there. And we broke out of he got the clearance. He broke out of the cloud, and there were towers of cloud. It's just night, and it's moonlight. It was just the most beautiful experiences I've ever had in a balloon. We're climbing 500 feet a minute fairly briskly, going up next to these towers of moonlit cloud. And we got above all that. It was a fantastic, beautiful experience. And most of the flight was just a matter of flying and watching, making sure everything was working. One of the things we were going to do was try to set a not very important altitude record, because in Roziere balloons they're not good for altitude records to start with. They're good for flying level for long periods and not for going up to a really high place. But Steve was collecting records, so I had brought bags of play sand. When the time came to do the altitude record, we heated up as much as was reasonable. Now, heating a lot is a bad thing because you drive out gas and you never get it back. Of course, we didn't care because we send that. But then we also I poured out those bags of sand. Steve handed them up to me, and I poured them over the side to light the balloon. Basically, we were already ascending, and then we poured a bunch of sand over to light it up and get up as high as we could. So we got to 28,000 feet, something like that. Then we started a long descent, 500 feet a minute, down and down.
You climbed up to an altitude of 27,447 feet, which is 5.2 miles. And doing any activity beyond 22,000 feet is so strenuous because even breathing is tough, right, in the thin air. Of course, you had oxygen, but still, it was pretty strenuous, right?
We were breathing oxygen, but I don't know exactly how strenuous it is. But once you're breathing oxygen, you're in good shape. A long descent, and that's when I was feeling kind of under the weather. on that flight. The weird thing was we got lower and our intent was to land around sunrise or the after and so on. So we're somewhere in Kansas. And both of us were standing in the hatch, which is really hard because there's not a lot of space in there. And water started pouring down from the envelope.
Oh my God.
What I realized was that there had been all kinds of condensation. What happens is when a balloon burner produces tremendous amounts of water because the byproducts of combustion are, water and CO2. A lot of that water, because it was so cold, it had frozen onto the bottom. So we're standing in the hatch and a stream of water is pouring down on us. The weather was really nice. But we're also going some crazy speed. We're going like 35 knots. I remember 40 knots at 3,000 feet. We're going way too fast. So, but we slowed down as we came down.
Mm-hmm.
And we were flying almost right down Minor Road out in the country. Steve was ready to put it down on the road, but I said, Steve, wait till we're past the road sign, because if we drag into that, we're going to destroy the envelope. We did that and ended up deflating on the side of the road, which was good because the fields were muddy. The strange thing about that flight, this says something about my memory of my visual memory, is I was on a flight from Dallas to Detroit, a commercial flight, and I was sitting looking out the window. I thought, wait a minute, that looks familiar. And I was able to pick out, just by chance, the exact spot where Steve and I landed on that flight from 30,000 feet. Just by chance, I'd recognize the pattern of the roads. There's a couple major roads,
right?
Unusual. And I thought, wait a minute, that's familiar.
How was the experience of flying with Steve? Did it give you a better sense of who he was as a person?
I think it was after that flight. I talked to Tim Cole, the guy who'd flown the Atlantic Ocean with Steve. And I said, Steve didn't talk much. It was 8 hours. And I said, we had almost no conversation on that flight. And he said, when we flew, and I talked to Tim for like about 5 minutes by then on the conversation. And he said, when Steve and I flew the Atlantic, it was 3 days. 3 days. I think it was
3 days, 3 hours.
Yeah, very good. Yeah. He said, Steve and I didn't talk as much as you and I have already talked in this conversation.
Oh, God, that's very wildly silent.
My sense is that Steve didn't like having other people fly with him. Okay. He liked flying alone. Okay. I shouldn't, all the fall of my balloon competition, I flew alone. So I shouldn't cast aspersions on people who like flying alone. But he just liked flying alone, and he was polite, but not very interested in conversation.
I guess that was his intrinsic nature, just to be alone, solitude and adventure, right? Yeah. I was surprised to learn that most of the media and the world altitude record only listed Steve, even though you had the idea, you were the one who prepared, arranged, and flew the balloon most of the time. Were you able to address that or get recognition for your contributions later on?
That was a learning experience as much as anything about Steve. It's one of the reasons I quit working with him, because after that flight, I designed that entire flight. I did all the flight planning and told Steve what we were going to do. So I thought I had a pretty big imprint on that not very important world record. And I didn't really address it directly. I wrote him a letter actually and said, I'm thinking I'm not really interested in continuing doing the launches. I have other things I want to do in life, and this is it takes a lot of time, et cetera, et cetera. But I didn't really want to address that actually. But he called, and we had a phone conversation, and I did raise that point. And the reason it was important to me was a lot of my friends after that flight were asking me, I read about this flight where Steve Fossett did this world record. And I said, I thought you went on that flight and there was no mention of you. And I mean, after about the fifth person, that kind of bothered me because as you know, I'm a person of note in the world of ballooning.
Yeah.
And then disappeared. Didn't sit well with me.
Mhm.
And I mean, I told Steve, I told Steve that, when he called and asked me, because he was really trying to get me to keep working with him. And he made the comment, well, the person who writes the checks gets the, uh, recognition.
Publicity.
Well,
Yeah.
recognition, I guess, yeah, or publicity. Anyway, I don't know, about a week later, this giant framed certificate arrived from the National Air and Space, or sorry, the National Aeronautics Association, listing Steve Fossett, as the pilot and Bruce Comstock as a co-pilot or something like that.
Mm.
So he'd obviously called them, but that was, in a sense, that was too little, too late.
Yeah. Yeah. But however, you did help him with the preparations, and you were the launch director for the second round the world attempt. For that, he flew halfway around the world from St. Louis to India because he had already promised you would be helping. So the second round the world attempt took place after the shakedown flight, right?
Yeah, the one from St.
Yeah.
Louis. The conversation I just described, I had after that flight.
Okay.
I hadn't made any decisions by then, but thinking about that after that flight was over is when I thought, do I really want to keep doing this? And part of my decision was I thought I should have had some recognition
Yes.
for that record flight, and that just didn't sit well with me.
Yeah, especially since you had contributed to the Atlantic flight, you were the launch director for the Pacific flight, launch director for the round the world attempts, and then you had the shakedown flight with him. So that was your incredible accomplishments in ballooning earned you a place in both the international and US ballooning halls of fame. Congratulations, it was a well-deserved honor for you. But if we can now take a step back and go to your early interests and first flights, your passion for ballooning had to start somewhere. What led you to ballooning?
There was a time, it's hard for people to realize that now. I started ballooning 55 years ago. There was a time when almost no one had seen a balloon. There was virtually nothing in TV or in the press about balloons. And I saw a balloon fly by. I was mowing my lawn in my little starter house when I was a graduate student at the University of Michigan. It was a one-person balloon on a plastic surgeon who lives about a couple of miles from us. And I grabbed my then wife and we hopped in our Volkswagen and chased after him and talked to him where he landed. And I was just awed. I mean, awed by the fact that this was possible and that somebody was doing this. It's hard for me to describe. I witnessed something that didn't exist. Suddenly, here's this thing, this guy flying in a balloon. You gotta be kidding. But I'm looking at it when we talked to him. As a graduate student, I couldn't think about getting involved in ballooning. But so it was a couple of years, and 2 years maybe, to when I got information at that point about balloons and realized that there was no way I could do it because they were $5,000 for a two-person balloon. So then several years later, we took a $5 helicopter ride from a field over the woods next to it and back to the field next to a carnival that was happening. And I had gotten this information about what balloons cost and where you could possibly get them and so on. When I was in that helicopter flying over the woods next to the field where we took off, I thought, I didn't particularly like this, all this noise and vibration, but I thought, what would it be like to be here in a hot balloon?
Yeah.
That could be really cool. So then I went home. By then I was gainfully employed, and I went home and pulled out my file on ballooning and got a hold of the company in South Dakota, which is responsible looking one. And they said there was someone who could teach me an hour north of where I lived. I got a hold of it. Spent the summer driving up there when our schedules allowed and the weather was good. and higher blood pilot's license.
You and your wife at the time, Tucker, discovered ballooning together. Did sharing that enthusiasm strengthen your passion for flying and shape your individual ballooning journeys? Because Tucker is also a highly accomplished balloonist now, right? So
Yeah, he was inducted into the U.S. Ballooning Hall of Fame a couple of years ago.
Yeah.
We did everything together. I couldn't have done a fraction of what I did in ballooning without the fact that the two of us were working together. And I once apologized long after we were divorced. We're still friends. I talked to her 4 days ago. I thought, well, maybe I dragged her through all this stuff and that it was my passion to do these things and she was just being dragged along. I apologized for that. She said, no, the things we did at Cameron Balloons when we were manufacturing, I couldn't have done any of that without you. You're the one who made that possible. My balloon competition, I couldn't have done the balloon competition without her, for example. I don't know. I can't even think about that. I can't even imagine how I would have done any of that. I'd suggest something like, we could do such and such. Oh, that would be pretty cool. And she'd just get right on board.
So, yeah, go ahead.
So it's really a team thing. I think it's hard. People say that very often, husbands and wives, but she did important pieces of what needed to be done in a lot of these things. Like in manufacturing, definitely. Between the two of us, we had all the skills we needed, but they were different.
Yeah.
And one of us could have done that. But doing it together, we were able to do it. And we were both determined enough that nothing was going to stop us. Very often when I think about now in a year since I've been away from the balloon manufacturing and that decision we made after I won the world championship to start manufacturing balloons, my reaction is, what were we thinking? The chances that we could succeed.
Yeah. By 1971, you had received your commercial license, correct? And you were even giving pilot instructions. Was there enough interest in ballooning that time? Did you have enough students? We're talking about 1971 when ballooning was still in its infancy, correct?
I got all there was is a commercial license, and I got it in September 25th, 1970. And then I think it was New Year's Day. I don't know how we'd met this guy, Dave Claggett.
Yes.
Wanted to learn how to fly balloons. So I started training him. It wasn't a great money-making thing because we were using our ballooning to teach someone else how to fly. So we had all that basic expense, but also we're using our opportunities to do other things in ballooning.
Yeah. Now, on that flight with Dave Claggett, I remember reading you got caught in a thermal. Yeah, could you please describe that incident? That might have been your first exposure to thermal?
I think it was because it was remarkable. That was an interesting day. It was something like Memorial Day, 1971. And we flew in the morning. That was great because that's the right time to fly, it turns out. It was such a beautiful day. It was so calm. We thought, wow, this is a day we could fly all day. So we took off at something like 1 PM, which is the worst time to take off.
Yeah.
And we went up fairly high and flew across Ann Arbor. Quite beautiful. And then we came down not far from Ann Arbor Airport on the south side, but got down close to ground over a field. And the balloon, it was very calm. It just came down gently and everything was wonderful. Then the balloon started moving suddenly and made a circle, and it rotated one time, went around this little circle over this field. It's about 100, 200 feet. And then went up. And we went up to something like 500, 600 feet. The deal with thermals is the important thing was to not let the balloon cool, because when the thermal dumps you out, you'll come down. And the burners back in those days were pathetic. They couldn't really stop quickly. So I kept the envelope warm. And then we stopped going up. And then we started going up again. This time we went up to 1,200 feet. And then we got out of it. Then I started looking for a place to land. That involves coming down kind of gently and so on. Oddly, whenever we got down to about 300 feet, it was like the bottom dropped out. We started accelerating downward. It was nerve-wracking. And finally, we came to a big field and waited until we were getting towards the center of the field and let the balloon come down fairly aggressively, even if we hit hard. I just ripped the deflation panel open and we landed. It was uneventful in the end, but it was nerve-wracking. But that was a lesson. That's the wrong time of day to fly. I used to, after I moved out to Oregon, I started flying paragliders, and I learned that the time to take off, if you want really, really good lift, the beginning of really good lift is about 1 in the afternoon. It can go up 1,000 feet a minute. But that takes all your control away in a balloon.
Once on one of those early training flights, I think you were a student and you were flying with Professor Frank.
Richard.
Okay. And he stopped heating the balloon during what is called a terminal velocity descent. That unsettled you a little bit when he stopped the burner, and then you heated up the burner and the balloon returned to level flight and you were fine. What is terminal velocity descent and when is it used in balloons?
Actually, at the time, I think it's true now that to get a private license, you need to go to 3,000 feet. You need to fly the balloon to 3,000 feet under control. I don't know if you have to do a terminal descent, but at the time I did it, it had to be 5,000 feet. Frank, who was not a professor, used that nomenclature. And Denny was Captain Fogg. Denny flew, and the guy doing my main part of instruction. Frank went along, and also his daughter went along. She's about 18 years old. I've known her.
Leslie, right?
Yeah, Leslie. I've known her for 55 years now.
Mm.
The way that flight went is I was flying a balloon. It says the rule is you have to make a flight in control to 5,000 feet and then descend cold. And cold isn't really cold, it's just that you don't heat. But the balloon isn't really cold. It doesn't make you cool that fast.
Okay.
You come down fairly quickly, like 1,000 feet a minute, which is noticeable when you're flying under a 50-foot diameter bag of air.
By 1993, you had won more U.S. championships than anyone else. You had also ranked high in world championships. What were your favorite games? Did you practice for them?
Practice makes perfect.
Over the course of your career, how have you seen ballooning evolve in terms of technology and challenges?
The balloons are better now than they were 50 years ago.
Yeah.
I competed for 23 years continuously. In my later years, my last decade anyway, I was flying a balloon that had a burner that had 13 times the heat output. The balloon I learned on a balloon that had, on a good day, had 4 million B2 per hour heat output. And about 1 million of that goes to just keeping the balloon in the air. And if it wasn't a good day, like if it's a winter and the fuel pressure is lower, you'd have less heat output, but it still takes 1 million BTU per hour to keep the balloon in the air. And if it wasn't a good day, like if it's a winter and the fuel pressure is lower, you'd have less heat output, but it still takes 1 million BTU per hour to keep the balloon in the air. When in competition, I was flying a balloon. If I turned everything on my double burner, turned everything on, which you could do in seconds, it had heat output of 52 million B2 per hour. So there's a lot more than I learned on. But what I've said many times is if you learned on a dead balloon, in my original balloon, it made you a good pilot because you had to pay attention and be on top of what was going on because you couldn't use power that you didn't have to solve the problem.
Yeah.
So the balloon I learned in was an aluminum gondola with a kind of a fiberglass floor that came up a little bit in the ways on the side. Mostly it was just an open structure.
Mm-hmm.
And then, all balloons now have baskets.
Yeah.
They're fairly sophisticated. I mean, there's all kinds of structural elements hidden inside those baskets, but they flex. So when you crash into the ground, hard landing, you don't hurt yourself. I used to have bruises on my legs, my first balloon, because it was kind of unforgiving for hard landers. It was very rigid metal structure. And
Yeah.
then two big 20-gallon tanks, one on each end, lay down tanks. So you end up banging your legs against. Everything about balloons has improved. The fabrics have been highly developed. They're not just off the shelf fabric. They're specifically designed and created for use in higher balloons. The burners are way better. I mean, it's like no comparison.
And hydrogen ballooning is very popular these days too, right?
I'm not sure I'd say highly popular, but it is popular. People are doing it.
Mm-hmm.
Helium is hard to come by.
Yeah.
Because there are a lot of competing uses like MRI machines. Some people find they can't even buy helium. I built a balloon with a friend years ago, a guy who had tried to do a round-the-world balloon flight, kept more than halfway around. But afterwards, I thought, why don't we just build a balloon and we can fly it in a race from Albuquerque each year. So by the time we got it built, we designed a balloon and built it, a gas balloon. It's never been inflated, because by the time we were done building it, the cost of helium for an inflation would have been $10,000. That, unfortunately. But hydrogen's perfectly reasonable.
What are your thoughts on the future of ballooning? What do you think about space tourism using balloons? Or just in ballooning in general, the future of ballooning?
I have a strange perspective on that. I've been thinking about that a lot in recent days since you invited me to do this. When I started ballooning, I had the opportunity to be effectively a pioneer in something.
Yes.
There was nobody to tell me how to do it. They could tell me the basics, but in the big picture is like, what can you do with this thing? And what are the right things to do and what are the wrong things to try to do? But the most important thing, let's think about this morning, is that when I saw this opportunity, I thought, wow. I mean, it was just so far from reality. But I also realized we could do this. And everyone I told about, like my associates at work, thought I was crazy. Most of them were polite. But the very idea of anybody flying in the line was kind of weird, like something people couldn't grasp. The normal reaction was there was no way anybody would do that. For me to be saying, I'm going to do this, it was an easy decision, but apparently for most people at that time, it was crazy to even consider doing it. It was actually perfectly sensible. It's just different. I thought long and hard about all the pieces of this, like, am I nuts or is this a reasonable thing to do? And I concluded it was a reasonable thing to do. Most people don't even get to the beginning of that thought process.
Yeah.
But there's something about me that made me willing to do that, know that. I don't know what that thing is, but I'm willing to go to the edges of reality.
Yeah.
It's reasonable and safe, and why not? But it was also a gigantic opportunity at the time, because I got to do something as a kind of a pioneer that almost nobody was doing. Now, the reason I meant this is that now nobody can do that. It's like with airplanes. Even when I went to learn to fly an airplane in the 70s or starting in the 60s and the 70s, everything was structured. This is how you do this. This is how you do this. You have to do it. Everything was decided for you. All you are is doing everything the way you're supposed to do it. I didn't have the opportunity to be a pioneer in airplane flying. I probably would have been bad at it. I'm not a very good airplane pilot, but I do have a license. But in ballooning,
Yes.
I started at not the very beginning, but virtually the very beginning, and got to have those kind of experiences. And when I discovered ballooning and actually started ballooning, I really engaged with it. I mean, both my wife and I really engaged with it. We did everything, as you know, from reading the book.
You had the first repair facility in the US.
Yes.
The balloon repair facility. And then, of course, you set up a big balloon manufacturing company too. So you were one of those pioneers. because that time ballooning needed so much improvement in all areas. Even as a child, you were building things or dissecting them, hearing aids, radios, or go-karts. That naturally carried into ballooning, which needed some effort, and you were there that time. So you've contributed a lot to ballooning.
It was engaging, which is why we engaged. At least to me and my wife, it was this very engaging opportunity, and we both ended up leaving our responsible jobs and
Yes.
and ultimately in manufacturing. But none of that was foolish decision. It was wise. And like, with the manufacturing, I really enjoyed the process of creating an efficient manufacturing process and facility. I eventually got bored with it because I'd done everything I could do. And I didn't realize until after I was away from Cameron Brothers that what was really attractive to me is what I just described, and that is the process of building good balloons. And that took a period of years, actually, but eventually I'd done everything I could do, to improve that process.
Yeah.
Got kind of boring because we're just getting orders and building balloons and delivering.
Yeah.
That's not what gives me. That's not what gets me up in the morning.
Are you involved in any lighter than air activities or flying now?
Well, I haven't flown for a couple of years, but 2 years ago, my now wife visited Ann Arbor and visited the factory, which is really a cool thing because she got to see this thing that I've talked about. I went for a flight. Andy got a balloon out. And that was really pretty cool because he and his wife were in the back lawn at Cameron, US, blowing air in the balloon. It was getting pretty close to time for the burner to inflate the balloon. Andy was standing on the other side and I walked around and said, "Hey, Andy, can I inflate the balloon? I promise I won't burn it." He said, "Yeah, sure." So I asked him, I wasn't used to that burner. I asked him to brief me on the rear valves, and he did. And then I inflated the balloon, and he got in, and Karen got in, and pulled the inflation harness release, and it gently drifted off. And I piloted the entire flight. I hadn't flown a balloon for quite a while now. I had a balloon out in Oregon for years. The problem is it's little mountain valleys where you can fly. The only time you can fly is in the morning. And you can't leave the little mountain valley because the retrieve would be incredibly complicated once you go over a hill. So I found that to be kind of boring. In fact, I flew the balloon. We had to drive down in Northern California to Shasta Valley, big valley, in the morning. And the valley's filled with cold air at night. So there's basically no wind. When I calculated once for the 4 flights, the average speed I'd gone, because I knew where I'd taken off, where I'd land on each one, and how long the flight was, I'd average 1 mile an hour, I think.
Okay.
You could crawl at that speed. And what I've said many times since, it's hard to get excited about flying at 1 mile an hour when you've flown about 100 miles an hour.
Is there anything important that I've overlooked? If you want to add, please feel free to add anything.
Well, I can blither all day long, You can ask questions like that. Incredibly fortunate and grateful for the fact that I fell into ballooning or got sucked in or whatever it was. The ballooning came along and I recognized an opportunity and took it. That led to a really interesting life. So now, as I like to say, when I go into a balloon museum, I feel like one of the artifacts. My ballooning happened between 1970 and 1995. The internet was just beginning to get organized in 1995. GoPro cameras didn't exist. And GPS barely existed by 1990. My first GPS, the one I used on my long jump flight, cost me $1,000.
Wow.
It's like, that was the beginnings of GPS.
Yeah.
So as far as photos go, the other weird thing is that during competition, we took no photos. because we're completely involved competing.
Thank you so much, and all the best in everything that you do.
Thank you. Same to
Yes.
you.
Bruce, thank you for sharing your incredible journey. From record flights to behind the scenes breakthroughs, you've shown us what the spirit of ballooning is all about. And friends, remember, these feats were done without the tools we take for granted today. No GPS to guide the way, no constant weather reports, almost no communication support. Yet, balloonists still dared to push higher, farther, and longer, driven by courage, skill, and imagination. If you would like to go deeper, Bruce's book, A Life in the Air, is a powerful read. Thank you for joining me. I look forward to bringing you more stories from lighter than air, science, and flight. See you soon.